The Bermuda Triangle, a name synonymous with mystery, fear, and inexplicable disappearances, is not a geographically recognized region, nor is it marked by international cartographers. It is a strictly conceptual, journalistic construct, a massive and ill-defined area of the western North Atlantic Ocean whose reputation has been built entirely on sensationalized accounts of vanished ships and aircraft. To properly analyze the phenomena attributed to this region, we must first define its conventional, though entirely arbitrary, boundaries. The area is traditionally delineated by connecting 3 points on a map, forming a vast, irregular triangle. The 3 vertices are typically identified as Bermuda, the small British overseas territory in the north, San Juan, Puerto Rico in the south, and Miami, Florida on the continental United States mainland in the west. This conceptual area covers approximately 500,000 square miles of open ocean, a colossal expanse that encompasses some of the world's busiest shipping lanes and air routes. This immense size is a critical, often overlooked fact. The region is so vast that any statistical analysis of disappearances must take into account the sheer volume of traffic passing through it. The territory includes sections of the continental shelf, deep ocean abysses, and the highly complex confluence of some of the Atlantic's most powerful oceanic currents. The depth within the triangle varies dramatically, ranging from the shallow waters over the Bahamas Bank to the profound darkness of the Puerto Rico Trench, the deepest point in the Atlantic Ocean, plunging to depths exceeding 27,000 feet. This varied topography is crucial to understanding the complex weather patterns and oceanographic forces at play. The myth suggests that the rate of disappearances within this zone is extraordinarily high, far surpassing any other comparable area of the world. However, the objective statistical reality tells a much different story, one that immediately begins to erode the foundation of the supernatural claims. Lloyd's of London, the internationally respected insurance market, does not recognize the Bermuda Triangle as an area of particularly high risk and does not charge higher premiums for travel through it. Likewise, the United States Coast Guard, which is responsible for maritime safety and search and rescue operations in the region, has repeatedly stated that there is no evidence to suggest that the total number of losses in the area is disproportionately greater than any other heavily traveled ocean corridor. In fact, when adjusted for traffic volume, the rate of incidence is comparable to, or even lower than, other major shipping routes such as the South China Sea or the coastal waters off northern Europe. The Coast Guard attributes the losses to the same mundane factors that cause all maritime incidents: unpredictable weather, navigational errors, and human inexperience. The initial statistical analysis, therefore, immediately begins to dismantle the legend. The Bermuda Triangle is statistically unremarkable. Its uniqueness lies not in its danger, but in the relentless, sensationalized media coverage that has artificially inflated the number and nature of the accidents occurring within its ill-defined bounds. To understand the mystery, we must look beyond the geographic boundaries and delve into the creation of the legend itself, understanding how a perfectly ordinary, if geographically challenging area of the Atlantic was transformed into the world's most terrifying maritime myth.
The myth of the Bermuda Triangle is a relatively recent invention, primarily a product of 20th century journalism and sensationalist literature. but its roots are often anecdotally traced back to the earliest European voyages of discovery in the region, most notably the journals of Christopher Columbus. While Columbus's accounts do not specifically mention a triangle of doom, they describe phenomena that later writers would co-opt as the foundational building blocks of the legend, linking the mystery to the dawn of the New World's exploration. In his log entries from his first voyage in 1492, Columbus recorded several unusual observations while sailing through the area. He noted instances of erratic compass behavior, with the needle pointing to true north rather than magnetic north, a phenomenon that was startling to his crew and led to momentary panic. He also recorded witnessing a massive, inexplicable flame of fire dropping into the sea one night, and several weeks later seeing a strange, shimmering light in the distance. While these phenomena are easily explained today, the compass variations were due to crossing the agonic line, where magnetic north aligns with true north, and the lights were likely a meteor or volcanic activity. These early documented events established a historical precedent for the area's weirdness. For centuries, the area, especially the coastal waters of the Carolinas and the Bahamas, remained a treacherous zone due to piracy, severe hurricanes, and the difficulties of navigation on the shallow, complex coral reefs. These factors contributed to a naturally high shipwreck rate, transforming the seabed into a genuine graveyard of historical vessels. However, the specific modern myth of the Bermuda Triangle as a zone of paranormal disappearance did not solidify until the mid-20th century. The legend was truly born out of a single, highly publicized event, the loss of Flight 19 in 1945, an incident whose spectacular nature and lack of debris captured the public imagination. Following this tragedy, a number of sensationalized articles began appearing. The term Bermuda Triangle was officially coined in 1964 by writer Vincent Gaddis in a Pulp magazine article titled "The Deadly Bermuda Triangle," which synthesized previous scattered accounts of mysterious losses into a cohesive, fear-inducing narrative. Gaddis retrospectively linked dozens of maritime and aviation incidents over the preceding decades, including the spectacular 1918 vanishing of the USS Cyclops, suggesting they were all connected by a single, inexplicable force within this specific geographic region. The legend was further cemented by popular authors, most notably Charles Berlitz, whose 1974 international bestseller, The Bermuda Triangle, disregarded scientific explanations entirely, attributing the disappearances to highly speculative and supernatural causes, ranging from time warps and alien abductions to the interference of a lost civilization such as Atlantis. Berlitz's book achieved massive commercial success, transforming the concept from a niche journalistic curiosity into a global cultural phenomenon. The shift from historical fact, challenging navigation and real hazards, to supernatural myth, an energy vortex that swallows ships, was complete. The birth of the legend, therefore, is not an ancient mystery, but a modern case study in how selective reporting, the power of a compelling name, and a disregard for statistical analysis can create an enduring, terrifying mythos out of routine maritime accidents in a heavily trafficked but entirely normal stretch of the Atlantic Ocean. The true mystery is not the disappearances, but how the legend managed to persist against overwhelming scientific debunking.
The catastrophic disappearance of Flight 19 on December 5, 1945, is the single most important event in the Bermuda Triangle mythos, providing the spectacular, inexplicable core upon which the entire modern legend was constructed.
The loss was so bewildering, 5 U.S. Navy Avenger torpedo bombers vanishing without a trace, followed by the disappearance of a large PBM Mariner search plane sent to find them, that it forced the U.S. Navy to conduct a massive, though ultimately inconclusive investigation, creating a perfect vacuum for supernatural speculation. Flight 19 consisted of 5 Grumman TBM Avenger torpedo bombers departing from the Naval Air Station in Fort Lauderdale, Florida, for a routine training navigation exercise known as Navigation Problem Number 1. The flight was led by the experienced pilot, Lieutenant Charles Carroll Taylor, a veteran combat flyer who, while new to the base, was highly proficient. The rest of the crew were advanced trainees. The routine mission was to fly east for 141 miles, drop practice bombs, turn north for 73 miles, and then turn southwest back to base. However, approximately 90 minutes into the flight, Lieutenant Taylor radioed the tower in a state of confusion, reporting that his compasses had failed and that he was unsure of his position. Crucially, Taylor believed he was over the Florida Keys, but based on subsequent radio transmissions, the flight was actually far to the east, over the Bahamas. The air traffic controllers and other pilots listening in struggled for the next 2 hours to guide the flight back to land. The pilots became increasingly disoriented and were heard arguing over which direction to fly, making increasingly poor decisions, including repeatedly flying over the same areas. The radio transcripts captured the growing panic, which became the central theme of the tragedy. One pilot was heard to say, "Everything is wrong. We can't be sure of any direction. Everything looks strange. Even the ocean doesn't look as it should." As dusk turned to darkness and the planes ran critically low on fuel, the final desperate transmission was heard. The entire flight group, 14 men and 5 aircraft, vanished somewhere off the coast of Florida, presumed to have ditched when their fuel ran out. To compound the disaster, a massive PBM Mariner flying boat carrying a crew of 13 and specifically sent out to search for Flight 19 also disappeared approximately 20 minutes after takeoff. The Navy's subsequent investigation found no debris from any of the 6 aircraft. The official Navy report was initially inconclusive, but a review board eventually concluded that the accident was likely due to pilot error, specifically the misjudgment and confusion of Lieutenant Taylor, who mistook the islands below for the Florida Keys, leading the entire flight off course and into the open Atlantic. However, Taylor's mother successfully lobbied to have the official finding amended to "cause unknown," fearing it would unjustly tarnish her son's reputation. This official "cause unknown" finding provided the ultimate fuel for the mystery. The combination of an experienced pilot becoming disoriented, the simultaneous failure of multiple compasses, likely due to flying over magnetic anomalies or severe radio interference, the increasing panic, and the subsequent vanishing of the rescue plane, likely due to the highly volatile fuel vapors of the PBM Mariner igniting, provided the sensational narrative of a supernatural force at work. Flight 19 was the ultimate loss. A well-equipped group of military aircraft, led by a veteran pilot, seemingly swallowed whole by a malevolent sea.
Decades before Flight 19 cemented the modern legend, the single largest loss of life in U.S. Navy history, not directly due to combat, occurred within the Bermuda Triangle's traditional boundaries. The inexplicable disappearance of the USS Cyclops in March 1918. The vanishing of this massive naval collier, a ship designed to carry coal, with its full complement of 306 crew and passengers, remains one of the most compelling and confounding maritime mysteries of the 20th century, adding immense historical weight to the region's infamous reputation. The Cyclops was an enormous vessel for its time, over 540 feet long, and was engaged in transporting manganese ore, a dense and highly specialized cargo, from Brazil to Baltimore during World War I. After leaving Rio de Janeiro in January 1918, the ship made an unscheduled stop in Barbados in early March to take on supplies. It departed Barbados on March 4, 1918, and was never seen or heard from again. No distress signal was received, no wreckage was ever found, and no definitive explanation for its disappearance has ever been formally accepted. The total lack of debris or a distress signal immediately led to sensational speculation, but the circumstances surrounding the Cyclops provide several entirely plausible, non-supernatural explanations that, when considered together, make its loss a complex maritime disaster rather than a paranormal event. The first and most likely explanation is structural failure and weather. The Cyclops was known to have structural problems. It had suffered an engine casualty earlier in the voyage, and its internal frame was known to flex excessively in heavy seas. Furthermore, the immense cargo of manganese ore, which is extremely heavy and dense, was likely loaded unevenly, creating a highly unstable condition. The ship was known to be listing to one side when it left Barbados. Critically, the vessel sailed directly into a sudden, ferocious hurricane-force storm sometime after leaving port. The combination of a structurally weakened hull, an unstable dense cargo, and a powerful storm is a textbook recipe for catastrophic sinking. If the ship sank rapidly, a distress signal may have been impossible to send, and the heavy manganese cargo would have dragged the huge vessel quickly to the bottom, explaining the lack of floating debris. A second strong theory involves sabotage and mutiny. Given the context of World War I and the fact that the Cyclops' captain, Lieutenant Commander George Worley, who was born in Germany and whose competence was questioned by his crew, was known to be heavy-handed and unpopular, the Navy did investigate the possibility of its capture by a German U-boat or even a mutiny orchestrated by the German-born captain. While no concrete evidence of U-boat activity in that specific area was found, the possibility of an internal plot cannot be entirely dismissed. The loss of the USS Cyclops remains a true historical mystery only because the physical evidence is absent. However, the scientific evidence of the ship's structural state, the highly unstable nature of its cargo, and the documented presence of severe weather provide a comprehensive, albeit circumstantial, explanation rooted firmly in the hazardous realities of early 20th century maritime travel. The vanishing of a massive, heavily laden ship due to a sudden storm and structural failure is a tragic maritime accident, but one that was seamlessly absorbed into the growing myth of the Bermuda Triangle's supernatural power.
While the legend of the Bermuda Triangle thrives on the idea of an external, inexplicable force, the overwhelming consensus among maritime and aviation experts is that the vast majority of disappearances can be attributed to the human factor, a combination of pilot or captain error, inexperience, poor decision-making, and the psychological effects of panic under duress. In a region where weather changes violently and navigation is inherently complex, the human element becomes the weakest link in the safety chain. The coastal waters off Florida and the Bahamas are an immensely popular region for pleasure boating and private aviation. This traffic includes a disproportionately high number of recreational boaters, private pilots, and smaller vessels that are often inadequately equipped or helmed by inexperienced individuals.
Unlike large commercial vessels or military aircraft, these smaller operators often lack proper training in deep-water navigation, celestial fixes, or the management of extreme weather. A common scenario involves a pleasure boat leaving the Florida coast with insufficient fuel, minimal safety equipment, and a skipper who relies solely on consumer-grade electronic GPS, unaware of the rapid current changes or the sudden onset of powerful squalls. When faced with an unexpected emergency, the lack of training quickly escalates a minor mechanical issue into a major disaster. Navigational error is perhaps the most frequent cause of reported incidents. The Bermuda Triangle encompasses the area where navigators must contend with the significant and often fluctuating difference between true north and magnetic north, the agonic line. For pilots and sailors relying on older magnetic compasses or failing to adjust their instruments correctly, this variation can lead to catastrophic miscalculations, placing them dozens of miles off course in the open ocean without reliable landmarks. The Flight 19 tragedy is the quintessential example of navigational error spiraling into disaster. Lieutenant Taylor's initial belief that he was over the Florida Keys when he was actually over the Bahamas led to a series of poor course corrections, ultimately guiding the flight group to exhaustion and ditching in the open sea. Panic and communication failure compound the problem. The radio transcripts from Flight 19, which captured the increasing fear and confusion among the pilots, illustrate how the psychological stress of being lost, particularly when instruments fail, can lead to irrational decisions and a breakdown in communication with ground control. In a hostile maritime environment, the ability to make clear, logical decisions is the difference between survival and disappearance. When inexperienced individuals are confronted with a sudden, overwhelming event, such as a rogue wave or a violent thunderstorm, the resulting panic can lead to a failure to send a distress signal, a refusal to abandon ship safely, or a fatal course correction. Finally, the role of insurance fraud and misreporting cannot be ignored. Some alleged disappearances in the Bermuda Triangle are suspected to be cases of owners intentionally sinking older, unseaworthy vessels to collect insurance money. These cases are often obscured by the sheer magnitude of the natural hazards, allowing the deliberate sinking to be masked as a mysterious vanishing. The human factor, the mistakes, the lack of training, the bad decisions, and the occasional criminal act provides a comprehensive and thoroughly scientific explanation for the vast majority of losses attributed to the supernatural power of the Bermuda Triangle. The true danger in the triangle lies not in the environment itself, but in the fallibility of the people who venture into it unprepared.
The Bermuda Triangle is a region of exceptional oceanographic complexity, dominated by powerful, swift, and highly unstable currents that make it one of the most challenging environments in the world for maritime navigation and, crucially, for search and rescue operations. The single most significant oceanographic feature defining the triangle is the Gulf Stream, a massive, warm, and rapid ocean current that flows up from the Gulf of Mexico, skirts the coast of Florida, and courses directly through the western section of the triangle towards the North Atlantic. The Gulf Stream is often described as a massive liquid river within the ocean, moving at speeds of up to 5 knots, which is about 5.7 miles per hour. This speed is fast enough to profoundly affect the navigation of small vessels, constantly pushing them off course if the captain fails to make appropriate continuous corrections. For a small boat with a low-powered engine, the Gulf Stream can be an almost irresistible force, making an accidental diversion into the open Atlantic a very real possibility. Furthermore, the Gulf Stream's speed and temperature create an environment of extreme thermal contrast with the cooler surrounding waters. This contrast is a key ingredient for the formation of sudden, violent weather phenomena. When cool air from the continent mixes with the warm, moisture-laden air above the Gulf Stream, the resulting instability leads to the rapid formation of intense squalls, thunderstorms, and powerful waterspouts, vertical rotating columns of air that form over a body of water, akin to oceanic tornadoes. These sudden storms can appear almost instantaneously, giving small vessels or aircraft virtually no time to react or take evasive action, leading to sudden capsizing or downing. The current's second, darker role lies in its effect on debris and wreckage. The Gulf Stream acts as an immense, high-speed conveyor belt, capable of sweeping wreckage and small debris far out into the open Atlantic within hours of an incident. A vessel that sinks rapidly or an aircraft that ditches may leave only small, scattered pieces of debris on the surface. Within a day, these fragments can be distributed over hundreds of square miles, pulled rapidly away from the point of loss and rendering traditional search patterns ineffective. This oceanographic reality provides the scientific explanation for the most enduring part of the Bermuda Triangle myth: the lack of debris. The idea that ships and planes vanish without a trace is not supernatural. It is the inevitable consequence of a powerful, fast-moving ocean current that effectively cleans up the crime scene, dispersing the physical evidence over a vast area of the ocean, far beyond the initial search grid. This scattering makes it appear as though the vessel or aircraft simply dematerialized, when in fact, the wreckage has been carried away by one of the world's most powerful natural forces. The Gulf Stream and the complex current system of the Western Atlantic, therefore, provide a comprehensive scientific antidote to the supernatural myth. The ocean is not magically swallowing vessels. It is utilizing its natural physical power to destroy the physical evidence of ordinary maritime tragedies.
The meteorological profile of the Bermuda Triangle is one of chronic instability and sudden violent extremes, providing a powerful natural explanation for the rapid destruction and disappearance of both ships and aircraft. The area's position at the confluence of powerful air masses and ocean currents transforms it into a breeding ground for weather phenomena that are challenging even for large modern vessels. The most common and lethal threat in the triangle is the sudden violent storm or squall line. As warm tropical air from the Caribbean meets cool, dry air from the North American continent, the resulting atmospheric instability can lead to the formation of localized thunderstorms that intensify with astonishing speed. These storms can generate near hurricane-force winds and torrential rains with almost no advance warning, particularly for smaller vessels lacking advanced radar systems. A boat or small plane caught in such a squall can be overwhelmed, capsized, or torn apart within minutes. The rapid onset of these meteorological events is a major factor in the no distress call aspect of the myth. A vessel may go from calm seas to catastrophic weather in the time it takes the crew to send a single radio message, explaining why so many disappearances are characterized by the sudden cessation of communications. A rarer but equally terrifying threat is the rogue wave, also known as an extreme wave or freak wave. While long dismissed as sailors' folklore, rogue waves are now scientifically proven to be real, non-linear phenomena. In the area of the Bermuda Triangle, these colossal, wall-like waves are likely generated by the interaction between the fast-moving Gulf Stream current and powerful opposing storm winds. When wind and current move against each other, the energy can stack up, creating an anomalous wave that can tower 2 or 3 times the height of the surrounding swell. A ship of any size, particularly if heavily laden or structurally unsound, that encounters a rogue wave head-on can be instantly overwhelmed. The wave can rip off the bridge, shatter the hull, or flood the engine room in a single devastating moment,
leading to rapid, silent sinking without time to deploy lifeboats or radio a distress signal. The area is also notorious for tropical cyclones and hurricanes. The triangle lies directly in the path of the primary hurricane corridor of the Atlantic, meaning that during hurricane season, June through November, the risk of encountering a Category 3 or higher storm is exceptionally high. While large vessels can track and attempt to avoid these massive systems, smaller vessels or poorly navigated aircraft can be caught directly in the hurricane's path, where survival is highly improbable. The meteorological extremes of the Bermuda Triangle are not magical. They are the quantifiable, violent expressions of natural forces. The area's unique geography and oceanography combine to produce some of the most challenging and rapidly changing weather conditions on Earth. These natural phenomena, sudden squalls, rogue waves, and waterspouts, provide a comprehensive and entirely non-supernatural explanation for the immediate destruction and subsequent vanishing without a trace that forms the tragic basis of the Bermuda Triangle legend. The sea is not supernatural. It is simply unforgiving.
One of the oldest, most persistent, and scientifically grounded theories attempting to explain the Bermuda Triangle's navigational woes centers on the region's unique interaction with the Earth's magnetic field, the phenomena of compass variations and magnetic anomalies. This theory directly addresses the numerous historical accounts, dating back to Christopher Columbus, of instruments behaving erratically in the area, a confusion that is easily mistaken for a mysterious force. The core scientific concept is the difference between true north, the direction to the geographic North Pole, and magnetic north, the direction the needle of a compass points, which is the location of the geomagnetic North Pole. This difference is called magnetic declination, and it varies depending on a navigator's location on the planet. For mariners and pilots, understanding and constantly compensating for magnetic declination is essential for accurate navigation. The key feature of the Bermuda Triangle is that it encompasses the agonic line, an imaginary line on the Earth's surface where the magnetic declination is zero, meaning true north and magnetic north perfectly align. However, the region around this line is characterized by rapid and confusing changes in declination. As a navigator crosses this zone, the difference between true and magnetic north can swing dramatically, causing compasses to behave erratically or leading an uncompensated compass to provide a dangerously false reading. This effect is compounded by the fact that the magnetic field is not static. It constantly drifts, adding an element of unpredictability that can confuse pilots and sailors who rely on older charts or fail to adjust their instruments correctly. For the inexperienced or under-equipped navigator, a compass that begins to swing wildly or point to the wrong location can induce immediate panic, leading to fatal course corrections. The pilot of Flight 19, Lieutenant Taylor, famously reported that "both my compasses are out," a statement that perfectly fits the profile of a severe magnetic anomaly or a gross navigational error compounded by magnetic declination. If Taylor failed to compensate for the declination or was caught in an area of severe local variation, his instruments would have shown a direction that was wildly inaccurate relative to the geographic reality. A second aspect of this theory involves localized magnetic anomalies caused by the region's complex geology, specifically the vast, submerged features of the Caribbean Plate and the Atlantic Basin. Large deposits of magnetic metals, like iron ore, or areas of high volcanic activity on the ocean floor can create localized interference that temporarily throws off a magnetic compass. While these anomalies are not powerful enough to physically suck down a ship, they can certainly cause the brief, dramatic instrument failure necessary to induce panic, navigational error, and subsequent loss.
The theory of compass variations and magnetic anomalies provides a powerful, scientific explanation for the most commonly reported paranormal symptom of the triangle, erratic instruments, without resorting to the supernatural. The mysterious force is not an external energy vortex, but the predictable, though complex, interaction between Earth's magnetic field and the limitations of human technology and knowledge. The Bermuda Triangle is not a place where compasses fail magically. It is a region where they demand the highest level of human competence to be understood correctly.
Among the scientific explanations for the rapid, silent sinking of large vessels in the Bermuda Triangle, the theory involving underwater methane hydrate eruptions is one of the most compelling and potentially catastrophic. This geological phenomenon suggests a process where a ship can lose all buoyancy and sink instantly due to a massive release of gas from the ocean floor, providing a plausible, non-supernatural explanation for why large vessels sometimes vanish without a trace and without issuing a distress call. Methane hydrates are crystalline, ice-like solids composed of water and vast quantities of methane gas. These compounds form under conditions of high pressure and low temperature, typically found deep within the ocean floor sediment. The waters of the Bermuda Triangle, particularly on the continental slopes and in areas of deep sedimentary deposits off the coasts of Florida and the Carolinas, are known to contain massive reserves of these hydrates. The theory proposes that geological instability, perhaps a minor submarine earthquake, a shift in tectonic plates, or a massive sediment slide, can destabilize these hydrate deposits. When the pressure holding the methane in its solid, icy form is suddenly released, the gas rapidly transforms into its gaseous state. This immense volume of methane then travels upward through the water column in the form of a gigantic, turbulent bubble. When this massive methane bubble reaches the surface, it causes the local density of the water to drop dramatically. If a ship happens to be sailing directly over the area of the eruption, the water beneath its hull, now essentially a foamy, less dense fluid, can no longer support the vessel's weight. The ship instantly loses its buoyancy and sinks almost vertically, as if sailing into a hole in the water. The sinking would be so rapid and violent that the crew would have no time to react, send a distress signal, or even abandon ship. This effect explains the mysterious absence of distress signals and floating debris, as the ship is rapidly dragged down to the ocean floor by the sheer force of the collapse. While compelling, the methane hydrate theory has faced scientific challenges. Critics argue that while the mechanism is geologically sound, the depth at which the hydrates would need to be destabilized and the sheer volume of gas required to affect a large ship in deep water make the scenario highly improbable as a frequent cause of disaster. Furthermore, there is a lack of recent, definitive evidence of massive, sustained hydrate eruption events occurring in the Bermuda Triangle. Nevertheless, the theory provides a highly specific scientific mechanism for the most difficult part of the mystery to explain: the sudden, total loss of buoyancy for large ships. Unlike atmospheric storms, which offer some warning, or human error, which is predictable, a methane eruption is a truly sudden, catastrophic event that would present no warning, instantly overcoming even the largest and most well-prepared vessel. It is a powerful example of how the deep, unseen geology of the ocean floor, rather than paranormal forces, could be responsible for the region's most baffling maritime tragedies. The most statistically sound, yet often overlooked, explanation for the high number of incidents in the Bermuda Triangle is the simple historical fact that the region is an immense shipwreck graveyard.
a product of over 5 centuries of intense maritime activity combined with treacherous natural hazards. The total number of incidents attributed to the area is not extraordinary when measured against the massive historical volume of traffic that has passed through it. The area between Florida, the Bahamas, and the Caribbean has been the principal artery for European-American trade since the 16th century. For over 500 years, the return routes for Spanish treasure fleets, major British colonial trading vessels, and later American commercial shipping all funneled through this region. This sheer, sustained volume of traffic means that, statistically, the waters of the Triangle contain a naturally high number of lost vessels. This historical density is compounded by 2 persistent natural hazards. The first is the Bahamas Bank and the coastal reefs, vast areas of shallow water and razor-sharp coral reefs that have historically claimed thousands of ships that strayed even slightly from the established deep-water channels. Before modern navigation, any navigational error could quickly lead to a vessel being torn apart on the submerged coral. The second is the persistent presence of severe weather, hurricanes, tropical storms, and the sudden, violent squalls generated by the Gulf Stream. A region that has served as a primary trade route for half a millennium, constantly plagued by severe weather, is guaranteed to have a disproportionately high number of historical losses, simply by the laws of probability. For example, the waters off the coast of the Carolinas, often included in the Triangle's broader definition, are notoriously nicknamed the Graveyard of the Atlantic due to the convergence of the Labrador Current and the Gulf Stream, which creates rapid currents and shallow sandbars leading to thousands of wrecks over the centuries. The perception of a mystery is heavily influenced by selection bias. When an incident occurs in the Bermuda Triangle, it is immediately sensationalized and attributed to the myth. When a similar incident occurs in the North Sea or off the coast of Japan, it is reported as a routine, tragic maritime accident. The fame of the Triangle ensures that every sinking, every lost boat, and every distress call in this geographic region is recorded, cataloged, and amplified as proof of a supernatural phenomenon, artificially inflating the perception of danger. Furthermore, the very existence of the legend encourages poor analysis. When a plane or ship vanishes, the instinct of many media outlets and amateur investigators is to immediately jump to the paranormal rather than diligently investigate the mundane but lethal factors like mechanical failure, lack of fuel, or human error. The statistical analysis from the U.S. Coast Guard and Lloyd's of London confirms that the Bermuda Triangle is not a unique danger zone. It is a highly traveled, naturally hazardous area whose true uniqueness is its historical notoriety. The seabed of the Triangle is not littered with vessels destroyed by alien forces or time warps. It is a vast, silent museum of maritime history, holding the remains of ships claimed by centuries of hurricanes, human error, and the inevitable attrition of heavy, long-term oceanic traffic. The mystery is simply the accumulated history of human activity in a perpetually dangerous environment.
The mythology of the Bermuda Triangle is predicated on the foundational claim that the area exhibits an abnormally high, inexplicable loss rate for ships and aircraft, suggesting a risk so profound that it transcends normal maritime hazards. If this claim were genuinely true, it would necessitate a massive financial adjustment by the global financial institutions that underwrite marine and aviation safety. However, when the myth is subjected to the rigorous, data-driven scrutiny of the insurance industry and actuarial science, the sensational claims immediately collapse, revealing the Triangle to be, in economic terms, an entirely unremarkable area of ocean. The international insurance market, led by institutions such as Lloyd's of London,
operates on the principle of assessing risk based on hard statistical data, not on anecdotal evidence or popular folklore. Lloyd's, which has underwritten vessels traveling through the North Atlantic for centuries, has repeatedly and definitively stated that the Bermuda Triangle is not designated as a high-risk area. This is arguably the single most damning piece of evidence against the paranormal claims. If the area truly caused ships and planes to vanish at a rate disproportionate to the volume of traffic, insurance companies would be forced, by economic necessity, to charge exorbitant premiums for vessels traversing the zone to offset massive financial losses. The fact that the insurance rates for shipping and aviation routes passing through the conceptual boundaries of the Bermuda Triangle are identical to those charged for other busy, naturally hazardous sea lanes, such as the English Channel, the Mediterranean Sea, or the Caribbean Sea, demonstrates that, from a professional risk perspective, the danger is entirely routine. The data collected by the United States Coast Guard, USCG, the primary search and rescue authority for the Western North Atlantic, corroborates the insurance industry's position. The USCG maintains meticulous records of distress calls, search operations, and confirmed losses within its area of responsibility. Their analysis consistently shows that while the total number of incidents in the Bermuda Triangle is high, this is a simple function of the extremely heavy traffic volume that flows through the area, linking major ports in Florida, the Caribbean, and Europe. When the number of reported incidents is normalized and expressed as a rate of loss per 100,000 voyages or flights, the Bermuda Triangle's record is entirely consistent with other major transportation corridors. Furthermore, the USCG attributes the losses it investigates to the same mundane scientific causes found globally: unexpected severe weather, mechanical failure, and, overwhelmingly, human error and inadequate preparation. Actuarial science, the discipline of assessing financial risk in high-stakes situations, treats the Bermuda Triangle as a classic case study in statistical distortion. The myth thrives by aggregating centuries of losses over a vast area and comparing that total to smaller, less trafficked zones, thereby inflating the perceived risk. Scientific scrutiny, however, demands normalization and comparison to analogous high-traffic, high-hazard zones, a comparison the Triangle consistently fails to win. The financial reality of the Bermuda Triangle is the ultimate scientific debunking. No supernatural force is required to explain the normal flow of maritime accidents in a hazardous environment. If a mysterious force were truly at work, the most risk-averse industry on the planet would have long ago placed an uninsurable price tag on venturing into the zone. The silence of the actuaries, in this instance, speaks far louder than the loudest supernatural claims.
The frequent historical and anecdotal reports of instrument failure within the Bermuda Triangle, pilots reporting compasses going wild or navigation systems malfunctioning, have fueled a specific scientific theory that localized electromagnetic interference, EMI, rather than supernatural energy, is the true cause of the area's navigational woes. This theory connects the region's geographical peculiarities with the sensitivity of modern and historical electronic equipment. Electromagnetic interference refers to the disruption of an electrical or electronic device by an external electromagnetic field. While the previously discussed theory of magnetic declination accounts for compass variations, the EMI theory focuses on the potential for local phenomena to temporarily disrupt or completely scramble a vessel's entire suite of electronic navigation equipment, including GPS, radio communication, radar, and inertial navigation systems. One potential natural source of EMI is atmospheric electricity, particularly during the violent, sudden thunderstorms common in the Triangle due to the Gulf Stream's thermal contrast. These storms are often accompanied by massive, sustained electrical discharges and intense lightning activity. A vessel or aircraft passing through a highly charged zone could experience temporary, severe disruption to its electronic systems, leading to a total loss of directional guidance and communication in a moment of critical emergency. While lightning strikes are a known common hazard, the proximity of the Gulf Stream amplifies the electrical intensity of these storms. A second, more speculative source of localized EMI could be related to the deep-sea geological structure. The deep seabed of the triangle includes the vast Puerto Rico Trench and areas of tectonic activity. Geological stress, perhaps related to seismic activity or the movement of large, dense mineral deposits, could potentially generate subtle, localized, low-frequency electromagnetic fields. While the exact mechanism for this is not conclusively proven to be powerful enough to affect modern equipment, the historical evidence of compass and instrument erraticism remains. The vulnerability of the affected vessels is a crucial component of this theory. Many of the vessels lost in the triangle have been smaller, older, or poorly maintained private boats and aircraft. These vessels often lack the sophisticated shielding and redundancy built into large commercial and military vehicles. An older electronic system, or one with faulty wiring, is far more susceptible to even minor electromagnetic disruption. A transient EMI event that merely causes a slight flicker on a commercial vessel's radar might completely crash a poorly shielded private plane's navigation system, leaving the pilot instantly and dangerously disoriented. The final critical effect of EMI-induced failure is radio silence. If a localized electrical event or power surge simultaneously disables the primary navigation systems and the radio communication gear, the vessel is rendered silent, incapable of sending a distress signal. This explains the characteristic vanishing without a trace that defines the Bermuda Triangle myth. The silence is not supernatural dematerialization. It is the instantaneous failure of human technology due to a sudden, intense natural electrical event. Therefore, the mystery of instrument failure is likely a confluence of known natural factors, the magnetic challenges of the agonic line, and the intense electrical instability of tropical storms, all interacting with the technical limitations of the vessels passing through the zone.
The enduring power of the Bermuda Triangle myth owes less to any genuine scientific anomaly and everything to the crucial historical role played by sensationalist media, exaggerated accounts, and a pervasive lack of scientific rigor in popular reporting. The legend is a prime example of how a narrative, once established, can feed on itself, with each new, unexplained accident being immediately framed within the paranormal context, regardless of the true cause. The genesis of the modern myth in the mid-20th century was driven almost entirely by pulp magazines and popular authors seeking a dramatic hook. As established, the term Bermuda Triangle was coined by Vincent Gaddis in a 1964 magazine article that compiled disparate incidents and linked them under a single, terrifying concept. The narrative was then solidified by Charles Berlitz's 1974 international bestseller, The Bermuda Triangle. Berlitz's book and others like it consistently employed several key journalistic techniques that inflated the myth's credibility while undermining scientific truth. Selective reporting and omission of facts. Authors habitually included only those elements of a disaster that seemed mysterious, while omitting the crucial, mundane details that would provide a rational explanation. For example, a ship reported as mysteriously vanishing may have actually been reported as being severely unseaworthy before its voyage, overloaded with cargo, or sailing directly into a confirmed hurricane. These mundane facts, structural failure, instability, or severe weather, are consistently erased to maintain the supernatural allure. Retroactive inclusion. As the legend grew, authors retroactively pulled historical shipwrecks and plane crashes from decades past, incidents originally and rationally attributed to storms or navigation errors, and arbitrarily assigned them to the triangle to inflate the total number of unexplained losses. This intellectual sleight of hand ensured the list of mysteries was constantly growing, providing an artificial sense of persistent danger. The supernatural default. If a vessel vanished and no wreckage was immediately found, a common occurrence in the vast, deep, and fast-moving waters of the Gulf Stream, the media often defaulted to the paranormal explanation rather than accepting the scientific likelihood of rapid sinking and debris dispersal. The lack of evidence was presented not as a challenge to search and rescue, but as proof of a mysterious external force. The phenomenon creates a powerful feedback loop. A journalist writes a sensational piece about a recent boat loss, framing it as a triangle mystery. The public consumes the story. Subsequent, similar accidents are then interpreted through the filter of the established myth, ensuring the legend's perpetuation. This has resulted in a global public consensus that the triangle is an area of unique danger, a belief that is unsupported by insurance data, Coast Guard statistics, or scientific analysis. The media's role in creating and maintaining the Bermuda Triangle myth is a classic case study in the tension between entertainment and journalistic responsibility. The true solution to the Bermuda Triangle mystery involves not a scientific breakthrough, but a journalistic correction. A reframing of the losses as routine maritime accidents in a heavily trafficked, naturally treacherous region. A correction that unfortunately lacks the dramatic flair required to compete with tales of time warps and alien abductions.
The enduring mystery of the Bermuda Triangle has often provoked highly speculative theories about the presence of submerged structures or artifacts on the ocean floor, particularly those linked to the mythical lost continent of Atlantis. However, modern deep-sea geological surveys, mapping, and core sampling have systematically replaced these fanciful ideas with a clear, scientifically accurate understanding of the region's complex but entirely natural submarine topography. The Bermuda Triangle encompasses a region of immense geological diversity, from the shallow, submerged carbonate platforms of the Bahamas to the vast abyssal plains of the Atlantic. Most significantly, the area borders the Puerto Rico Trench, the deepest point in the entire Atlantic Ocean, plunging over 8,376 meters, or 27,480 feet, below the surface. This deep geology is the result of the collision between the North American and Caribbean tectonic plates. Far from revealing hidden civilizations, the geological investigations have confirmed the presence of the powerful natural forces responsible for shaping the environment. The deep-sea mapping, often conducted using sophisticated side-scan sonar, multi-beam echo sounders, and submersibles, has been essential in the search for the wreckage of famous losses like Flight 19 and the USS Cyclops.
This technology provides high-resolution images of the seabed, allowing scientists to identify sediment types, geological fault lines, and crucially, any man-made objects. Despite decades of intense mapping and searching for high-profile wrecks, there has been no credible evidence of pyramids, city walls, or any unnatural, manufactured structures on the deep-sea floor within the traditional boundaries of the Bermuda Triangle. Reports of underwater roads or submerged pyramids, often circulated by amateur researchers, have consistently been debunked by marine geologists who identify the features as natural rock formations, such as bathymetric anomalies, massive igneous rocks, or natural sediment patterns. The area is known for significant carbonate deposition and the movement of sediment due to strong bottom currents, which can naturally create angular or symmetrical features that, when viewed through blurry or speculative underwater photography, are misinterpreted as artificial structures. The deep-sea investigations have instead focused on the very real geological hazards. For instance, the presence of vast reserves of methane hydrates in the deep-sea sediments, as discussed previously, is a scientifically confirmed geological reality, proving that the ocean floor holds genuine, potentially catastrophic, natural phenomena that require no supernatural explanation. Similarly, the study of the complex network of submarine canyons and trenches helps explain why wreckage is so rarely found. When a vessel sinks in this area, the strong bottom currents and the steep, rugged topography of the canyons often carry the debris into inaccessible deep-sea locations, permanently burying or scattering the evidence over an immense vertical and horizontal area. The scientific investigation of the deep-sea floor in the Bermuda Triangle has effectively demystified the seabed. It confirms that the greatest threats come from natural forces, tectonic instability, powerful currents, and unstable geological features, and not from the remnants of a mythical advanced civilization. The deep ocean is not the site of an ancient mystery, but a modern-day scientific testament to the raw, natural power of Earth's geology.
The submarine topography and geological features of the Bermuda Triangle region are crucial to understanding the area's inherent hazards. The triangle's southern and eastern boundaries are heavily influenced by the presence of the Caribbean Trough and the deepest point in the entire Atlantic Ocean, the Puerto Rico Trench. This extreme variation in water depth and seabed structure contributes directly to navigational difficulties, weather extremes, and the impossibility of recovery after a disaster. The Puerto Rico Trench is located just north of the island of Puerto Rico and marks the boundary between the North American and Caribbean tectonic plates. It is a subduction zone where the Atlantic seabed is being forced beneath the Caribbean plate, creating immense geological stress. The sheer depth of the trench, plummeting over 8,300 meters, is a critical factor in the vanishing without a trace myth. Any vessel or aircraft that sinks into the trench's waters is instantly lost to depths that make salvage and recovery virtually impossible with current technology. Furthermore, the tectonic activity associated with the subduction zone means the area is prone to submarine earthquakes and landslides. A sudden seismic event could trigger the rapid destabilization of slopes along the continental shelf or within the trench, causing massive sediment slides that could generate local destructive waves or, as theorized, trigger the catastrophic release of methane hydrates. The surrounding area, including the Bahamas banks, presents a very different but equally lethal navigational challenge. These are vast, shallow submerged carbonate platforms, characterized by intricate networks of coral reefs and sandbars that pose an extreme hazard to maritime traffic. A vessel that successfully navigates the deep ocean can still be easily wrecked on the jagged, barely submerged coral reefs if a slight navigational error or a sudden storm pushes it off course.
the shallow water does not guarantee recovery. The abrasive nature of the coral and the intense wave action during storms can rapidly break up a wooden or metal hull, scattering the wreckage in the complex reef system and making it extremely difficult to locate. The combination of these extreme geological features, the precipitous crushing depth of the trench, juxtaposed with the shallow reef-laden banks, creates a unique maritime environment where a mistake can quickly lead to either immediate, violent destruction on the coral or irreversible sinking into the Atlantic's deepest chasms. The submarine topography dictates the severity of the loss. If an incident occurs over the shallow banks, the wreckage is often scattered and inaccessible due to the reefs. If it occurs over the deep trench, the evidence is simply swallowed by the abyss. The Caribbean Trough and its surrounding geological features thus provide a complete and scientifically grounded explanation for the diverse yet devastating types of losses recorded in the Triangle, without the need for supernatural portals or mysterious energies. The true mystery is the unforgiving nature of the Earth's deep-sea structure.
The persistent anecdotal accounts of complete instrument failure in the Bermuda Triangle, ranging from radios going silent to compasses spinning wildly, are often cited as key evidence for a supernatural interference field. However, scientific analysis attributes these glitches not to a mysterious energy, but to a predictable convergence of known environmental stressors, technological limitations, and simple human error. The gravity of these glitches is amplified only by the consequences they incur in an already hazardous environment. We have established the role of magnetic declination and the agonic line in causing magnetic compasses to behave erratically. This is not a malfunction, but a predictable consequence of crossing a zone where the difference between true north and magnetic north changes rapidly. The failure lies in the pilot or navigator's inability to correctly compensate for this known geographical phenomenon. The spinning compass is not a sign of a mysterious force. It is a sign of a magnetic compass struggling to find alignment in an area of high field variability. Similarly, the frequent reports of radio and communication failure are not mysterious. They are often directly correlated with the region's severe meteorological extremes. The intense electrical activity, including lightning strikes and massive static charges within the violent, sudden squalls generated by the Gulf Stream, can cause severe electromagnetic interference, EMI. A strong electrical surge can temporarily or permanently scramble poorly shielded electronic equipment, including communication radios and GPS units. The apparent radio silence is often the result of this instantaneous electrical failure, which prevents the crew from transmitting a distress signal before the vessel is overwhelmed by the storm. The problem is often compounded by the vulnerability of the equipment. Many of the reported incidents involve small, privately owned boats and planes. Unlike military or commercial vessels, which utilize redundant and heavily shielded navigation and communication systems, private craft are often equipped with consumer-grade electronics that are far more susceptible to transient electrical surges or atmospheric interference. A small voltage spike that a larger ship could easily handle might be enough to simultaneously disable a smaller plane's entire electronic suite, creating the dangerous illusion of a total systemic failure caused by an external force. Furthermore, the role of cognitive bias cannot be ignored. When a pilot encounters an intense storm, a sudden mechanical failure, or a moment of disorientation, the existing myth of the Bermuda Triangle immediately provides a ready-made, terrifying explanation. It must be the triangle. This psychological factor can compound stress and lead to panic,
causing the pilot to focus on the mythological cause rather than diligently troubleshooting the real mechanical or navigational issue at hand. The glitches in the Bermuda Triangle are merely the cumulative effect of a complex magnetic environment, intense atmospheric electricity, and the inherent limits of human technology. The true mystery is how these routine, scientifically verifiable technical failures have been consistently misdiagnosed as proof of the supernatural, demonstrating the power of myth over empirical observation.
Beyond the major meteorological events like hurricanes and rogue waves, the Bermuda Triangle region is routinely threatened by highly localized, smaller-scale natural hazards that possess the destructive power to sink or destroy a vessel in an instant, explaining yet another facet of the vanishing without a trace phenomenon: waterspouts and ocean vortices. These phenomena are natural, quantifiable, and lethal. Waterspouts are essentially intense columnar vortices that form over a body of water, visually similar to a land tornado. They are extremely common in the tropical and subtropical waters of the Bermuda Triangle, especially during periods of high humidity and atmospheric instability, which are often created by the contrasting temperatures of the Gulf Stream. A waterspout forms when a cold air mass moves over a body of warm water, leading to a rapid vertical development of clouds and rotation. These columns of rapidly spinning air can range from a few feet to hundreds of feet wide and possess immense destructive power. A waterspout that passes directly over a small to medium-sized vessel can lift the vessel out of the water, tear off its mast and superstructure, or instantly capsize it. The event is typically over in minutes, but the resulting damage is catastrophic and often unrecoverable. For pilots of small, low-flying aircraft, a waterspout poses an invisible, violent threat. If a plane accidentally flies into the vortex, the extreme turbulence and wind shear can cause immediate structural failure or loss of control, sending the aircraft into the sea before the pilot can issue a coherent distress call. The destructive power and transient nature of waterspouts offer a perfect, non-supernatural explanation for small craft being instantly destroyed and leaving minimal debris. Ocean vortices and strong local eddies, while less visually dramatic than waterspouts, also pose a significant hazard. The powerful, fast-moving Gulf Stream can generate intense, localized swirling currents or eddies as it interacts with the complex seabed topography, particularly near the shallow banks and deep trenches. These powerful vortices can temporarily trap smaller vessels, making them difficult to steer and impossible to move against the force of the swirling water. While these currents are unlikely to physically pull a large ship underwater, they can exhaust a small vessel's fuel reserves, damage its steering mechanism, or place it on an unforeseen collision course with a reef, leading to eventual loss. Furthermore, the turbulence associated with these vortices contributes to the extreme difficulty of search and rescue. The rotating water rapidly disperses any debris or life jackets, further contributing to the illusion that the vessel simply dematerialized. The presence of waterspouts and ocean vortices confirms that the Bermuda Triangle is a region where the natural environment utilizes highly concentrated, localized energy, air and water, to destroy and scatter the evidence of its victims. The mystery is not a magical force, but the sheer speed and localized intensity of the destructive weather and current systems that operate in this volatile region. The single most powerful force perpetuating the Bermuda Triangle myth is not found in the ocean or the sky, but in the human mind. The legend is sustained by fundamental cognitive biases, systematic errors in thinking that lead people to believe the supernatural explanation, even when faced with overwhelming scientific evidence to the contrary. Understanding these biases is key to debunking the myth. The primary cognitive bias at work is confirmation bias. This is the tendency for people to search for, interpret, favor, and recall information that confirms or supports their prior beliefs or values. When an incident occurs in the Bermuda Triangle, a person who already believes in the myth will immediately seize on the lack of debris or the pilot's final confused radio call as proof of the paranormal force. Conversely, they will instinctively discount or ignore the rational explanations: the presence of a hurricane, the unseaworthy condition of the vessel, or the pilot's documented inexperience. Confirmation bias allows the sensational narrative to override mundane facts. Selective memory and availability heuristic work hand in hand to amplify the perceived danger. The availability heuristic is the mental shortcut that causes people to estimate the probability of an event based on the ease with which examples come to mind. Because the media has spent 60 years sensationalizing the losses in the Bermuda Triangle, the stories of vanishing planes are immediately and vividly available in public memory. This makes people overestimate the area's actual risk compared to other regions. When a ship sinks in the Triangle, the story is highly memorable and is added to the mental catalog of unexplained mysteries. When a ship sinks off the coast of New Jersey or in the Gulf of Mexico, often under similar conditions, the story is quickly forgotten because it lacks the sensational framework, creating a selective memory that reinforces the triangle's uniqueness. Finally, the myth benefits from apophenia, the tendency to perceive meaningful connections between unrelated things. The legend is built entirely on taking dozens of disparate centuries-old maritime and aviation accidents, each with its own unique and often mundane cause: storms, fire, engine failure, and forcing them into a single cohesive narrative under the umbrella of the triangle. The human mind naturally seeks patterns and explanations, and the idea of a single powerful energy vortex is far more satisfying than the statistical truth that each loss was an independent, tragic event caused by entirely routine factors. The persistence of the Bermuda Triangle myth is a testament to the power of human psychology over objective data. The scientific analysis proves that the area is not uniquely dangerous. The psychological analysis proves that the human mind is uniquely prone to believing a good story over a complex, statistical truth. The real riddle of the triangle is not why ships sink there, but why people are so deeply invested in believing they sink for supernatural reasons.
To definitively debunk the myth of the Bermuda Triangle, it is essential to compare its statistical track record and natural hazards to other recognized high-risk maritime zones around the globe. This comparative analysis, which the sensational accounts consistently fail to perform, demonstrates that the Triangle is merely one of many naturally hazardous corridors, and in several key metrics, it is demonstrably safer than its contemporaries. The core claim of the Triangle is its unique danger. However, the South China Sea, a region encompassing major shipping lanes in Southeast Asia, far surpasses the Bermuda Triangle in both density of traffic and actual risk. The South China Sea is plagued by frequent, violent typhoons, complex currents, political disputes, and a far higher documented rate of both maritime collisions and piracy. If the sheer number of losses were the metric for a paranormal zone, the South China Sea would be a far stronger candidate for a Devil's Sea due to its quantifiable lethal hazards. Similarly, the waters around the Cape of Good Hope, South Africa, and Cape Horn, South America, are historically and currently far more treacherous. These regions are characterized by the convergence of massive cold and warm currents, which generate perpetual high seas, unpredictable winds, and the extreme phenomenon of rogue waves at a frequency significantly higher than in the Atlantic. The historical loss rate around these capes, due to the extreme meteorological conditions, is vastly higher than anything recorded in the Bermuda Triangle. The true scientific analog to the Bermuda Triangle, particularly in its susceptibility to sudden, violent weather, is the Great Lakes region of North America. The lakes, which see massive commercial and recreational traffic, are notorious for the sudden onset of powerful localized storms, or witches of November, which have swallowed large ships in minutes. The mechanism, a combination of cold air over warm water causing rapid squalls, is essentially the same as the Gulf Stream's effect on the Triangle. Yet no one attributes the loss of the Edmund Fitzgerald to supernatural forces. The cause is accepted as pure, overwhelming meteorological power. The statistical comparison is the ultimate scientific refutation. According to the United States Coast Guard and international insurance data, the rate of loss per voyage in the Bermuda Triangle is not only lower than major global shipping arteries like the South China Sea, but it is also comparable to, or in some cases lower than, the overall average for oceanic travel worldwide. The reason for the high total number of incidents is purely mathematical. It is one of the most heavily trafficked regions in the world, linking 3 massive continents. The scientific conclusion is that the Bermuda Triangle is a heavily populated highway with its share of sharp turns and bad weather, whereas zones like the South China Sea or Cape Horn are poorly maintained, permanently storm-swept backcountry roads. The ultimate verdict of this comparative analysis is that the Bermuda Triangle is not an anomaly. It is merely a geographical location whose routine dangers have been amplified by a self-perpetuating mythos, failing every objective test when stacked against the genuinely dangerous, scientifically documented high-risk zones of global maritime travel.
The journey into the Bermuda Triangle, once framed as a search for the supernatural, concludes with a comprehensive, evidence-based understanding that its mystery is not defined by external, unexplained forces, but by the entirely predictable, albeit lethal, convergence of natural phenomena and human fallibility. The separation of myth from maritime fact reveals a story of challenging geography, extreme weather, and the enduring power of a good story. The foundation of the myth, the claim of a uniquely high loss rate, is scientifically demolished by actuarial reality. The fact that international insurance markets do not charge higher premiums for the area, and that the U.S. Coast Guard statistics confirm a loss rate comparable to any other heavily trafficked route, proves the danger is routine, not anomalous. The vast majority of disappearances are conclusively explained by a deadly combination of 5 key quantifiable factors. First, the human factor, the disproportionate presence of inexperienced recreational sailors and pilots in an area demanding expert navigation, leading to fatal errors in judgment. Second, the oceanographic reality of the powerful, swift Gulf Stream, which acts as a colossal conveyor belt, rapidly removing and scattering wreckage and debris, creating the illusion of a vanishing without a trace. Third, the meteorological extremes, the sudden, violent onset of squalls, hurricanes, and the potential for rogue waves generated by the thermal contrast between the Gulf Stream and cool air, capable of sinking a ship in minutes without time for a distress call. Fourth, the geological hazards, the complex submarine topography of shallow, reef-laden banks, and the sheer, crushing depth of the Puerto Rico Trench, which ensure that wreckage is either quickly scattered or permanently lost to the abyss. Finally, the cognitive bias, the power of the media-fueled legend to overshadow mundane truth, with every accident being retroactively attributed to the paranormal, creating a self-fulfilling prophecy of mystery. While individual cases like the USS Cyclops and the subsequent vanishing of the rescue plane for Flight 19 remain true historical puzzles due to the absence of recovered wreckage,
The scientific framework provides the probable solution: rapid sinking due to structural failure or explosion, followed by the immediate dispersal of all evidence by the Gulf Stream. There is no need for time warps, alien abductions, or lost Atlantean energy fields. The Bermuda Triangle is not a mysterious death trap. It is simply a vast, historically significant, and heavily traveled ocean corridor, whose routine, natural dangers have been magnified and distorted by the collective human desire for a supernatural explanation. The scientific truth is that the only magic at work is the relentless, unforgiving power of the Atlantic Ocean itself. We have peeled back the layers of sensationalism to find the truth. The Bermuda Triangle is a fascinating case study in oceanography, meteorology, and human psychology. The mystery is not supernatural. It is statistical. If the official story is a mundane one of human error and harsh weather, why does the myth endure so powerfully? Perhaps the true allure lies in our desire to believe that the ultimate danger is external and unexplainable, rather than the simple, terrifying fact that the greatest hazard in the sea is often ourselves. Now that you have the scientific facts, which explanation do you find most compelling? Methane eruptions, rogue waves, or simple human error? Join the discussion below. Share your thoughts on how a legend can become fact in the age of information. And subscribe for more deep scientific dives into the world's greatest mysteries. The sea is dangerous, but the truth is clear.